So hello everyone, welcome back to my channel. So in today's video, we are going to talk about the different types of fact tables, its key components and benefits of different types of fact table. So here in the center, you can see we have the data warehouse, and with this data warehouse, we create our analysis report, we create our reports on top of the data, we create data marts, we have fact tables, we have dimension tables on the basis of which we create a star schema, snowflake schema. We find out the hidden patterns in our data using data mining techniques. So in this video, we are going to dive deep into the different types of fact tables, and we will understand each of the fact tables with a example. So let's first start with what actually is a fact table. So a fact table is a table in a star schema or snowflake schema which holds the numerical data or quantitative data. And we have already talked about different types of dimensions. So if you haven't watched my previous video of the different types of dimensions, what actually are the dimensions, so please go through that video. So dimensions are nothing, just a descriptive attribute. So if you look at this Amazon order fact table example, so here you can see in this particular example we have this product ID, we have this customer ID, we have this date dimension, so which we are referring to as foreign keys. Foreign keys means these are the dimensions that this order fact table is connected to. Now, let's say we need to calculate the revenue, and this is the formula to calculate the revenue: unit price into quantity minus discount. This is how we will calculate the revenue, and this is all numeric. So, we do analysis on the numerical data, and the tables that holds this numerical or quantitative data is known as fact tables. Moving forward, let's say for this Amazon order fact tables, we need to find out this particular KPIs, that is total revenue, average order value, items per order, discount rate, top products per revenue. So these are the formula to calculate this particular KPIs, and these are all numericals. As you can see, these are all numbers. So this is what fact tables is. And if we need more information about that, this order is purchased by which particular customer, and this order is associated to which product, that is P101 is there, and we need to find out more details about this P101. So we have the different tables that is known as dimension table, product dimension tables, where we can know the details of this particular product as well. So this is what a fact tables is. Now let's talk about the different types of fact tables. So generally there are five types of fact tables. So first we will talk about this transaction fact tables. So here you can see this is the atomic truth. So here we took the example of Starbucks coffee, so it is just a demo example. So here you can see we have different transaction, we have a store ID, we have this barista ID, date key, item ID, quantity, price, loyalty points. So date key, so date dimensions is associated with the fact table so that we can know the details in details, at which date, at which particular time we have this transaction. So date key is a dimensions that is uh, you will see in most of the fact tables. So here you can see every coffee one row, and let's suppose your manager asks you to which barista sells most coffees on weekend, or what's the peak hour at a store as 101. So you can find out easily using this fact tables, because with this fact tables we have our numerical data available with which we can identify this easily. So let's say we need to find out this matrix, that is what are the transactions per hour. So we can easily find out using our fact tables what are the top items that is sold. So here you can see latte, and what are the loyalty points earned, so 8420. So in this way we can calculate the details using this fact tables, which are nothing but a numerical data, and the details for that data and the descriptive attributes is present in the dimension tables, and that are stored via this foreign key. So here you can see store ID S101. So this is like that. Transaction fact tables are additive, some quantity revenue points across any dimensions. For example, for finding for in transaction fact tables, we can calculate by connecting, by summing up all the dimensions. Okay, and this is perfect for detail analysis and fraud detection. This is perfect for fraud analysis and fraud detection. Now let's say ki if I am a customer, and if I buy two coffee let's say one latte and other one is croissant. So there will be two rows generated. It is not like that it will be in a single row that two orders will be placed by one particular customer and a latte and croissant are in the same row. No, this is what we called as atomic. Two rows are created for the two items. Now, here I have talked about this additive properties. So this additive, semi-additive and non-additive, these are the measures of the fact tables. So if I talk about additive measures, so what it actually means is that this can be summed up across all the dimensions. That is, for example, sales, barista ID. So we can have all this dimension included and we can find out the result using summing up all the dimensions. And similarly, we have the semi-additive measures as well. This can be summed across some dimensions but not others. For example, account balance, inventory level. So like this semi-additive measures. And then there are non-additive measures as well. This cannot be summed across any dimensions. For example, percentage, ratios. So these are not going to include any dimensions in it. But if I talk about additive measures, all the dimensions can be included. We can sum up all the dimension and we can find out the results. Okay, so this is known as transactions fact tables. And if I talk about the granular level, so I already told you that if I buy two different items, so this particular two item rows will be created. It's not like a single row will be created with these two orders because it will not be atomic then. So it is normalized and we have the two rows for two different items. So this is what the transaction fact tables are. Moving forward, we have this periodic snapshot fact tables. Periodic snapshot, the daily pulse, or if we need to find something over a period of time. For example, if you look at this example of this bank, so we have this different account ID, balance, available credit, overdraft, like these are some of the columns. So now let's say if I need to find out this KPIs, I need to find out average daily balance, I need to find a trend for 30 day, I need to find out what are this overdraft risk percentage. So I can easily find out using this periodic snapshot fact tables. So the name is very clear. If we need to find something over a period of time, then we will go for this periodic snapshot fact table. So what this periodic snapshot fact tables is that it summarizes business activities over a defined period of time, such as daily, exactly, or monthly. So this KPIs, you have the clear understanding that we are finding the average daily balance. So we are finding it on a daily basis, 30-day trend, overdraft risk. So this periodic snapshot fact tables is useful for trend analysis and stores semi-additive measure. That is, it doesn't sum up all the dimension but includes only particular dimensions for the analysis. So this is ideal for trend analysis over time. So this is what periodic snapshot fact tables are. Now, moving forward, there is type 3, which is accumulating a snapshot, which is a journey tracker. I have included this keyword journey tracker because it tracks the journey. For example, let's say this is the shipment table where we have this tracking number and we have this two tracking number. So suppose you order something and you have sent a link that this is your particular tracking ID. You can track your order with this particular link. And in this, we have the different status, that is picked up, in transit, in delivered. So what happens is that it will not create a record for each of the status. For example, if the order is picked up, one record is created. If a order is in transit, one record is created. No, it actually covers the cycle. For example, they update one row as the package moves. Picked up, in transit, delivered. This row is updated 4 to 5 times. No new records are inserted again. So this is the key factors to remember. Accumulating snapshots are updating the row, not inserting a new row. So in this also, a semi-additive measures are typically useful for tracking purposes with multiple stages. And if I talk about the KPI, so suppose if I need to find out on-time delivery, average days in transit. So this way, with this accumulating snapshot fact tables, I can easily calculate it and no new records will be inserted. Only the journey will be tracked. that is picked up in transit, delivered. So this will be updated 4 to 5 times, but no new records will be generated. So this is all about accumulating a snapshot. All right, now comes factless fact tables. So this this is a type of fact tables where there is no number, just proof of participation. For example, this is a data, student ID, course ID, semester ID, enroll date, and we need to find out this KPIs, that is what are the enrollments in CS50 section, what are the dual enrollments, what is the attendance rate. So we calculate this KPI. So this is only the participation KPIs. For example, if I talk about the colleges, they doesn't store grades here, just did the student enroll, yes or no. This is a factless fact tables, no measures, only keys. How many took both CS50 and State 110? If we want to find out this types of questions or this type of results, then we can simply use this factless fact tables. Which courses have highest co-enrollment? So this is a particular type of factless fact table where there is no number, just a proof of participation, yes or no. Or if we need to find out the details, that how many took both CS50, State 110, these are just example. So this is also a kind of fact tables that we use in our data warehouse. Now talking about the aggregated fact table. So with aggregation, you have the idea, right? Which is pre-summarized, fast, dashboard ready. So here you can see we have this facts monthly sales table. In this, we have this year, month, category ID, region ID, total sales, total units, average discount. So like this. And if we need to calculate this KPIs, that is monthly revenue, query time versus raw table, if we are going to do the monthly sales analysis on a raw table, and if we need to present it to someone, that is really slow. So we pre-summarized, we pre-calculate, we aggregate this sales via region or via category, and then we produce it to our end users so that they can query or they can go through this and they will understand what are the total sales that are made in this particular region. So if I talk about the example, so let's suppose Walmart's can't query Walmart's. So it has a lot of data. So it is not going to query the 10 billions record in a board meeting, or whenever they are creating the reports, or whenever they are sharing these reports with someone. They are not going to query the 10 billion records because it will impact the performance and all. So what we will do is we will aggregate this fact tables. We will know monthly sales by category, monthly sales by region, so which is 100 times faster. And we can use this aggregated fact tables when our executive need instant dashboard. You are building Power BI or Tableau reports on top of your data, because it is faster, it saves times, and it is 100 times more efficient and more performing than we are going to query the raw data and we are going to find out this. So this is where this aggregated fact tables will help us, which is pre-summarized, fast, and dashboard ready. That is, we can share it with the end user easily, and they can also see the details very fast. So this is what aggregate fact table is. Moving forward, now let's suppose which fact table should you choose. So you should ask yourself a question: if what happened, if there is any transaction happen, so use this transaction table. For trend analysis for a particular period of time, we can use periodic snapshot. We need to track something, so we can use accumulating snapshot. We know accumulating snapshot, no new records will be inserted, only the records are there that will be updating. For example, we have seen the example as well. Who attendant, there is no numerical values, just the presence that this particular party is involved. So we will use this factless table. Show me the Q3 sales. So I am going to use my aggregated fact tables. I will pre-aggregate my fact table so that I can produce the result faster and my end user can also consume the data faster. So this is it for this video. If you like this video, please like and subscribe to my channel. Thank you for watching.